Activity 3, areas and volumes of similar figures. Now that we have been able to establish a relationship between the scale factor, image length, and object length, let's try and see if we can establish a relationship between areas of objects and images, as well as the volumes of objects and images in relation to the scale factor of enlargement. So we'll go back to our GeoGebra window and we use this artifact to complete the tables in activity 3. So if you have your GeoGebra window set up, you can open the artifact and perform the activity. Now the artifact looks like this. We have two objects. We have a cube, which is the object, and then a bigger cube, which is the image. And for the object and image, we have sliders that will be adjusted, and for each adjustment we'll be able to record the total surface area of the object as well as the total surface area of the image. So we'll adjust the length of the cube. The length of the cube is L, and as you observe, when I adjust the length, the size of the cube changes, and the K is the scale factor of enlargement. And you observe that when I adjust the scale factor of enlargement, the size of the image also changes. So let's move on to activity 3 and adjust our sliders according to the descriptions in the table. So now we are to adjust the sliders, and we have to make sure that the scale factor of enlargement is equal to 1. So let's assume we have a scale factor of 1. And for the length of the object, you will notice that the total surface area remains the same no matter the size of the object. Okay, so we can make a recording here. We can choose any length of object we want. So I can say that when the length is equal to 1 unit, the total surface area of the object is 6, and the total surface area of the image is also 6. So we can record that here. So over here we observe that the total surface area of the object is, let's use centimeters for the units. So that will be 6 centimeters squared. The total surface area for the image is also 6 centimeters squared. Now let's try a scale factor of 2. We adjust the scale factor to 2 units. We have 2. And let's adjust the length of the object. So we have an example here. If the length is 2, we have the total surface area of the object to be 24, and the total surface area of the image to be 96. So we can record that. So for the object we had 24 centimeters squared, and for the image we had 96 centimeters squared. Let's try a scale factor of 3. So we adjust the scale factor to 3, and in the same way we can choose any length that we want. Let's use a length of 1. So with the scale factor being 3, we have a total surface area of the object to be 6, and the total surface area of the image to be 54. So we can record that here. So we have 6 centimeters squared, and then 54 centimeters squared. So now, carefully observe these recordings, and using our previous knowledge of the relationship between scale factor, image length, and object length, try and see if you can come up with a formula that connects the area of the object, the area of the image, and the scale factor of enlargement. Now, if you are able to do that, you would observe that you come up with a formula which is similar to this, whereby we have the scale factor squared is equal to the area of the image divided by the area of the object. Or, in order to find the area of the enlarged figure, that is the image, we would have to square the scale factor of enlargement and then multiply our result by the area of the object. Now let's check and see if that works. For example, if I want to get my area of the image, which is 54, I would have to square my scale factor of enlargement. So if I square this, which is 3 squared, I'll get 9. And if I multiply the 9 by the 6, 9 times 6 will give me 54. So it works here. Let's try this one. If I square this scale factor, which is 2 squared, I get 4. And when I multiply the 4 by the 24, I'll get 96. So the formula actually works. So we can say that the area of the image is equal to the scale factor squared times the area of the object. Now let's move on to the second part of the activity, where we are to make recordings of the volume of the object and the volume of the image. In the same way, let's adjust the scale factor. We have a scale factor of 1. And in recording the length of when we adjust the length of the object, we observe that the volume is the same for that of the object and that of the image. So we can record that here. We can say that the volume of the object, assuming we are using centimeters, so we have 8 cubic centimeters. We have the same 8 cubic centimeters. That is when the scale factor is 1. Now when the scale factor is 2, adjusting the scale factor to 2, we'll observe that here we are having a volume of objects to be 8 and the volume of the image to be 64. So let's record that. So we have the same 8 cubic centimeters, but we are having a volume of image to be 64 cubic centimeters. Now let's try a scale factor of 3. We adjust the scale factor to 3. We will observe that we are recording an object length of 8 and a volume of 216. So we can make that recordings. So we have the same 8 centimeters cubed. We are having 216 cubic centimeters. And we can also have a scale factor of 4 and make further recordings. Here we have a volume of 1 and the volume of the image is 64. So we can have 1 cubic centimeters. We're having 64 cubic centimeters. Now observe your recordings carefully and come up with a relation that connects the volume of the image, the volume of the object, and the scale factor of enlargement. Now if you are able to do that carefully, you would notice that we can come up with a relation like this, whereby when the scale factor is cubed, it will be equal to the volume of the image divided by the volume of the object. Or in other words, if you want to find the volume of the image, you would have to cube the scale factor, or give it an exponent of 3, then you multiply the result by the volume of the object. Let's check and see if it works for our recordings here. For example, with the first one, if I have 1 cubed, it is the same as 1, and 1 times 8 is equal to 8. If I have 2 cubed, that will be equal to 8. So if I use that to multiply the volume of the object, that will be 8 times 8, and that gives me 64. If I have 3 cubed, that gives me 27. If I multiply 8 by 27, I'll get 216. Also, if I have 4 cubed, which is 64, I can multiply the 64 by 1 and I get 64. So that is the relation that connects the volume of the image, the volume of the object, and the scale factor of enlargement. Now let's look at some applications and solve some further questions before we end here. For example, a figure of 10 centimeters squared and a volume of 25 cubic centimeters is enlarged with a scale factor of 2. Find the area and volume of the enlarged figure. Now, to find the area of the enlarged figure, we would have to square the scale factor and multiply it by the area of the object. So that is 2 squared times 10, that is 4 times 10, and that gives us 40 square centimeters as the area of the enlarged figure. And if you want the volume of the enlarged figure, which is the volume of the image, we would cube the scale factor, which is 2 cubed, times the volume of the object, which is 25. So 8 times 25 gives us 200 cubic centimeters as the volume of the image. Now there are several examples that we'll be solving later on, and scale factors are very important in real life. For example, the scale factor is used to scale shapes in different dimensions. Enlargement scale factors are used to draw similar figures and magnified objects in geometry, while reduction scale factors are used to draw and make scaled model blueprints of architecture and machinery. And mechanics, carpenters, and other skilled tradespeople also use scale factor of enlargement to create full-scale objects from tiny blueprints. Okay, so now in summary, we have been able to achieve our lesson objectives. We were able to describe the characteristics of enlargement under various conditions of the scale factor of enlargement. And we're able to establish that whenever the object and the image are on the same side of the center of enlargement, we have a positive scale factor. But when the object and the image are at opposite sides of the center of enlargement, we have a negative scale factor. And we also used our various formulas to solve questions involving finding the scale factor of enlargement. And we're able to establish that the scale factor of enlargement is obtained by dividing the image length by the corresponding object length. Conversely, we can also find the object length when we divide the image length by the scale factor. And also we can find the image length when we multiply the scale factor by the object length. And we're also able to use the GeoGebra artifacts to establish the relationship between areas and volumes of similar plane figures. And we observed that in finding the area of an image, we would have to square the scale factor of enlargement and multiply it by the area of the object. And if we want to find the volume of an image, we would have to cube the scale factor of enlargement and multiply it by the volume of the object. Now, how was the lesson? You can tell me how the lesson went and your experiences in the lesson by leaving some comments below. And if you have any questions, you can also put them in the comments below. So now there is a final exercise on our worksheets. That is activity 4. There are several questions that we can try our hands on to solve. For question 1, it says, describe the size and position of an enlargement with respect to the object size and position of the center of enlargement when the scale factor is A, 0.3, B, negative 1.5, and then C, 1. And then question 2, in the diagram below, triangle ABC is an enlargement of triangle AEF. A, calculate the scale factor of enlargement, and B, find the value of X. And question 3, in the figure below, triangle AXY prime is an enlargement of triangle ABC. A, find the scale factor of enlargement, and B, find the length of AC. Question 4. In the diagram below, square A prime, B prime, C prime, D prime is an enlargement of square ABCD from the center O. The area of square ABCD is 4 centimeters squared, and the scale factor is 1.5. Find the area of the enlargement square, which is A prime, B prime, C prime, D prime. Question 5. Figure A below is a cone that has a height of 24 centimeters and has a volume of 160 centimeters cubed. Figure B is an enlargement of figure A with a height of 72 centimeters. A, what was the scale factor of enlargement? And then B, what is the volume of the cone of height 72 centimeters? Okay, so now let's look at the answers for the worksheets. This is the completed table for activity 1. You can pause the video and compare them with your answers. And these are the solutions to questions in activity 2. You can pause the video and compare the answers to yours. And for activity 3, the answers can vary, so this is just a sample of what you are expected to do. And for activity 4, these are the answers for question 1, question 2, question 3, 4, and 5. So thank you for joining me in today's lesson. See you later for another lesson. Bye.